we know that the universe of which this planet is a part came into being very suddenly by a single act of creation some 15 billion years ago. And by a billion, I mean 1,000 million. So, prior to 15 billion years ago, there was no matter. There was no time. There was no space. And suddenly, in an instant, all three of these things were created out of nothing. Suddenly, all matter that was going to occupy the entire universe happened. And it happened by the explosion of a very tiny, very dense primeval particle. I'll tell you a little bit more about that particle later, but just accept for the moment that it was a very tiny, very dense particle, and it exploded suddenly at the beginning of time. And it exploded into a mass of hydrogen. And we're told that within 7 seconds, some of that hydrogen started to change into helium. And as the temperature and pressure decreased, some of the helium changed into lithium, and some of the lithium into beryllium, some of the beryllium into boron, some of the boron into carbon, some of the carbon into nitrogen, some of the nitrogen into oxygen. And I'll stop there. Of course, I could go right through Mendeljeev's periodic table of the elements. I only know 96 of them when I was at university. I think there are more than 100 that are known today. But I'll stop there because it is just carbon and oxygen that I wanted to introduce, because these two elements combined to form the gas carbon dioxide, which was the primeval atmosphere of our Earth when our Earth came into existence as part of the solar system 5 billion years ago, 5,000 million years ago. Now, 5,000 million years. Even as a geologist who deals with rocks of extraordinary antiquity, I find it impossible to conceptualize a span of time as long as 5 billion years. So to make it easier for myself to understand and for you to understand, I'm going to condense the history of this extraordinary planet of ours. I'm going to condense that 5 billion years into a time frame that we can conceptualize. I'm going to condense it into 1 year. Let's call it our Earth year, that our Earth came into being 1 year ago on the 1st of January, and we will see what has happened to the Earth stage by stage during that Earth year, and that will bring us eventually to the present moment, which will be the 31st of December of our Earth year at midnight. That will bring us to right now. So that's what we're going to do. If you will bear with me, we will look at the history of the Earth in a time frame of 12 months. And when we've done that, we'll start to look at what we human beings are doing to this planet of ours now. So we're going to start at midnight on the 1st of January with the, not with the Big Bang, the cosmic singularity where we had this great swirling mass of hydrogen. No, we're going to start with day 1 of our solar system. So here is a picture of our Milky Way, our galaxy, and our sun is one of 200,000 million stars in our galaxy. And our galaxy is one of 100,000 million galaxies all speeding away from each other at the speeds of thousands of kilometers per second. And if we trace their motions backwards in time, we find that they were all concentrated into a tiny sphere of radius 1/1000th of a centimeter, 15 billion years ago. Now, let me introduce the story of our planet by quoting from a lovely little book by Lewis Thomas called The Lives of a Cell, in which he says, viewed from the distance of the moon, the astonishing thing about the Earth, catching the breath, is that it is alive. The photographs show the dry, pounded surface of the moon in the foreground, dead as an old bone. But aloft, floating free beneath the moist, gleaming membrane of bright blue sky, is the rising Earth, the only exuberant thing in this part of the cosmos. And if you could look long enough, you would see the swirling of the great drifts of white cloud covering and uncovering the half-hidden masses of land. And if you had been looking a very long geological time, you could have seen the continents themselves in motion, drifting apart on their crustal plates, held aloft by the fire beneath. It has the organized, self-contained look of a live creature, full of information, marvelously skilled in handling the sun. So, let's have a quick look at some of the really significant things that have happened on this planet Earth. It didn't always look like this, because for the first 1/3 of its existence, that is, for the first 4 months of our Earth year, there was no life on Earth. It was an inorganic planet. And its atmosphere consisted predominantly of carbon dioxide. And the ocean appeared at the end of March of our Earth year, and exciting things started to develop in that ocean during April. And by the beginning of May of our Earth year, the Holy Ghost had breathed on the face of the ocean, and the first signs of life had appeared within it. Algae, the most primitive forms of vegetation that we still find in our swimming pools today. And these filamentous structures that are preserved as fossils in the ancient rocks of the Onverwacht group of strata here in the Transvaal. Isn't that a wonderful name? Onverwacht. It was totally onverwacht that in these strata we would find the most primitive forms of life anywhere on the Earth. You know, this is why the Transvaal has come to be known by the name that Robert Broom called it, the Cradle of Man. Yeah, possibly also the cradle of life itself. Because the algae here started this process of photosynthesis, absorbing the carbon out of the carbon dioxide atmosphere and liberating the oxygen. And we see, preserved in these very ancient rocks of the Onverwacht group, these small stromatolites. Can you see them there, those crenellated structures? Yes. right in the chert rocks of the Onverwacht group. And we know that the algae continued their photosynthesizing. They continued converting the oxygen from carbon dioxide into oxygen for a very long time. And here we see large algal stromatolites, beautifully preserved in the Transvaal Dolomites, which were deposited in a large, shallow inland ocean that occupied the Transvaal 2 billion years ago. That is on the 8th of August of our Earth year. Now, these were the only creatures alive, these very primitive forms of vegetation, the algae, nothing else, but they were busy converting the carbon dioxide into oxygen so that we can enjoy breathing oxygen here this evening. But those were the stromatolites, the algal colonies that we find still preserved in fossilized form today. And the algae continued this photosynthesis right up until the Waterberg sandstones were being deposited here in the Transvaal, the very first red strata to be deposited anywhere on the Earth. In other words, the very first strata containing rusted iron oxide, showing that the atmosphere by now, and by now I mean by the end of August of our Earth year, had become oxygenated and therefore fit to be breathed by animals, and the algae had taken more than 1.5 billion years to oxygenate the atmosphere and to pave the way for the evolution of animal life. This is a reconstruction of Gondwanaland by Professor James Kitching. Reconstruction of Gondwanaland 300 million years ago. In other words, on the 10th of December of our Earth year, we were still part of the supercontinent known as Gondwanaland, and the ocean occupies Gondwanaland from time to time, and by now it is teeming with invertebrates, animals without backbones. These extraordinarily beautiful animals without backbones. This one looks as though he could do with a backbone. Huh? And indeed, from 300 million years to 200 million years ago, in other words, from the 10th to the 14th of December of our Earth year, vertebrates evolved. Vertebrates, fish. And some of the fish that were brave enough to climb out onto dry land for part of their life became amphibians, and some of those that remained on dry land evolved into reptiles, and from the reptiles primitive mammals evolved. And if we move up to the 14th of December, that is 300 million years ago, this is what the parts of the Transvaal, which is now the coal fields and parts of Natal, this is what it looked like. This is an Eka coal forest on the 14th of December. You see the glaciers retreating in the background, but in the foreground you see this exuberant vegetation, this Glossopteris and Gangamopteris trees, the leaves of which accumulated over millions of years to form the coal that we mine and burn today. We'll speak about that a little later. Here's Lystrosaurus, a mammal-like reptile that lived in Harrismith. And here's an artist's impression of what this small dog-faced creature with a small tail looked like. And the wonderful thing about Lystrosaurus, which is why I've selected him to show you tonight, is because Lystrosaurus survived the greatest mass extinction of all time. at the end of what we geologists call the Permian period, 240 million years ago. In other words, on the 12th of December, when 96% of all species on our planet disappeared. They became extinct. But little Lastrosaurus managed to find his way through and gave rise eventually to Massospondylus, the dinosaur, this one from Clocolan. And there's been a wonderful recent discovery at Clarence. This creature, 15th of December, the Massospondylus and other dinosaurs were the lords of creation, roaming around the Transvaal and Natal. And I took a group of civil engineering students